have like this. So this will be the weight M1G, normal contact N1, here N1. The weight of this will be M2G. This normal contact will be N2. Under N1 M2G sine theta, the force that will be M2G plus N1 sine theta will make this to accelerate A2. This acceleration will be with respect to ground. This N2 will act normal and will resolve this also. Okay, till here this one. And this is rough. It's telling this is rough. This surface is rough. So we'll apply a pseudo force. This will be M1A2. Component of that will act towards right. Component of this force will act towards right. So this angle has to be theta. Then the frictional force will be. Then on the wedge, it will be this one. This is a rolling friction. It's a rolling friction. I think these are the free body diagrams what we must have. And let the acceleration with respect to this is a center of mass. Let this be AR, I'll write it. And it will have alpha. Let me write everything relative. We'll write the equations of motion first. We'll see what we can do further. So along the incline, for the motion along the incline. Along the incline, the forces acting will be M2G plus, here only writing, M2G plus N1 sine theta should be equal to M2A2. I do have other forces. Wait. What are the forces that will be? I think I may correct. Component of friction also should come. F cos theta, rolling friction. Then O will accelerate the hollow cylinder, uniform hollow cylinder. That should be equal to M1A2 cos theta minus F should be equal to M1 AR. Then F into R should be equal to IC into alpha R. Let me write it. Then can I write AR equal to R alpha R? Or we should not write? One more equation, N1 will you agree with this part?
Yes, sir.
Because we are describing motion with respect to, you should not go for again acceleration of this point, this point. If you are doing with respect to ground frame, then acceleration of this point should be equal to acceleration of this point. We are doing with respect to wedge frame. So this is very important. I think here is sometimes we may go wrong. because we got habituated, for no slipping acceleration of this point should be equal to this. Directly, we are describing the motion of cylinder with respect to wedge. So therefore, this is justified. No, of all this, this is very important. Somewhere we may go wrong. That's why this is very important. So all this will get answered. I'll write down. Find the acceleration of wedge. This should be equal to. I think doing in ground frame will be very lengthy. If you want to try it, very lengthy. Doing in wedge frame, the motion of cylinder in wedge frame will be much easier. I will scroll down. Very good problem. I brought it.